Hello, this is a demo of the forward plus lighting algorithm implemented in a cross-platform low-level rendering framework known as the Forge. What you're seeing right now is rendered using a regular forward lighting pass. Unfortunately, given some memory constraints, we're not able to showcase the end result using forward plus, but some visual aids will be given later on. So immediately what you're looking at is a total of 64 dynamic lights randomly generated throughout the geometry of the famous Sponza Castle scene. When toggling the profiler, you'll notice that we're rendering at a consistent 30 milliseconds per frame. 64 dynamic point lights approaches the limit at which a stable frame rate is possible given traditional forward rendering. As a visualization aid, we've implemented a heat map that illustrates the density of light per screen space frustum. Rather than performing lighting calculations for every light in the scene, Forward Plus provides performance gains by only performing light calculations for every light within a given frustum. For example, there's a good chance that a light influencing the top left of the screen will not be influencing the bottom right part of the screen. Thus, the light is only applied where there is influence rather than applying the light regardless, which is done in naive forward. A further improvement to Forward Plus is known as volume-tiled lighting. Right now, nothing is being done for overlapping lights. However, rather than dividing the screen into tiles, volume-tiled lighting divides the screen into cubes so that lights closer to the viewer occlude the further back lights, improving performance even more substantially. If this were done using volume-tiled lighting, there would be significantly less red areas where lights overlap. What you're seeing now is our Forward Plus implementation rendering over 1,000 lights at nearly 200 frames per second. The reason this looks so blocky is because we did not have enough memory to allocate more than one light per frustum. Thus, if you consider this teal tile in the middle, realistically, there's at least 500 lights influencing this tile. However, we only had enough memory to take into account a single light influencing that tile, which is why you're seeing a block of teal rather than a mixed block of multiple lights. Moreover, the reason why there are many black regions is the same reason. There's a light whose index is much closer to 0 than more relevant lights. It's just attenuated severely, leading to blackness. However, overall, the algorithm is complete from a technical standpoint. Figuring out some memory optimizations would provide great benefit and much better visuals.